All right, so classwork, group work, page 193, I think it is. And we're trying this thing. So help me out. If I was revolving this around the axis y equals 5, which is right here. I'm revolving around y equals 5. What are we going to do here? Any horizontal axis, probably going to go with what? So you got a washer method here, and washer does what? Whole minus the whole. But in this case, as I'm wrapping it around there, the whole, that's a nice constant radius. But what happens when you're doing the HOLE? There's two inner functions, right? So the whole is pretty easy, right? What do I have there? What do I do to find that? Pi what? I can go, how do I find the area of that washer? Of that disc, actually, the outer disc. Help me out here, guys.
Minus 0.
Okay, yeah, it's always 5, right? You can go 5 minus 0, but it's always 5. So I'm going to go pi 5 squared, which is pi times 25. Or 25 pi, whatever. I think most people kind of like having a little number in there for some reason. You can put them all in there if you want. And then I'm going to do that, give it a little what? Give it a little width, dx. And I'm going to integrate that from 1 to 9. Right? Little width was a little change in the x. And then what's the whole? For this one, I'm going to have to do 2. So how do I find that inner radius? It's going to be what? And that's the natural log function. So 5 minus the 2 ln x. So 5 minus the 2 ln x, that's the radius. So I'm going to pi r squared that. Right? 5 minus that is the radius. And then I'm going to give that little width. And I'm going to integrate that from 0 to what? 2.807. And you would have to.
0.
Because I made a mistake. Thank you. 1. And then I got to get rid of the other part of the HOLE. And that's going to be 5 minus the other function, negative 1/3 x plus 3. And I'm going to pi r squared that dx. And I'm going to do that from 2.807 to, I believe it's 9. But I can check that by plugging a 0 in for y and solving, and I get x equals 9.
Are you going to give us something like this?
And I need to subtract that too. Am I what?
Are you going to give us something like this? Where we flip through like 2 separate parts?
Oh, sure.
Okay. Cool.
Sure. I'm not going to give you like the whole test like that,
No.
but I certainly want to know that you know how to deal with if I have 2 holes, or maybe if I have 2 holes and 1 hole. But at AP, we'll do this for sure. Not a ton. They would consider, ooh, this is a hard one. Like, I mean, if they, now we're going to do that same rotation with something below, and you'll see it with 2 holes. But yeah, absolutely, they'll do that because they want to see that you're competent in that area as well. So same problem, but this time I'm going to revolve around y equals negative 1. So in this case, I have what? 2 holes. So first one. What do you got? So, okay. Pi what? Thanks. So 2 ln x minus the axis, right? So you're going from here to there for the outer. So minus -1 is +1. So there's your pi r squared. And you're fine to write minus -1, but I mean, whatever. I did that on a lot of my keys, not because I wanted to do that. I just wanted you to see where it was coming from. So that's your area of the outer. Give it a little width. Integrate from 1 to 2.807. And then I've got the other part of the hole. So I have to go hole 1 plus hole 2. I got to add those and then subtract off my hole. So the next one's what? Pi. Radius squared. What's your radius? What is it? There, the axis. It's changing. So -1/3 x plus 3. And then take that and subtract a -1. So you're adding 1 to that. So you could just make it +4. All right, minus the -1, whatever. Square it, give it a little width. And integrate that from 2.807 to 9. And then what am I getting rid of? So pi radius is always 1, right? 0 minus -1 is 1. So pi 1 squared. You don't have to write 1, but it makes you happy. Dx from 1 to 9. And again, I mean, it does feel a little, I don't know, alone on the inside there. But if it makes you happy to put 0 minus a -1 in parentheses squared or 1 squared, fine. But if you like putting the pi in there, I think somebody in my 7th period is like, sixth period, they're like, I like the pi in the inside. Fine. I got to be honest with you. I don't care. But I got to be honest with you. I forget it on the outside when I'm typing it in. It just, I don't know why. It's just usually you see constants like that factored out. But it's totally fine to leave it on this. All right. What about number 3? We're rotating it around 12. But I want you to do disk washer this time. So we're rotating it around x equals 12. The perfect time for shell, but I want disk washer. So what happens when I do this? Rotating it right here. I'm going to have to change my functions. So the first function was y equals 2 ln x. So I'm going to have to divide by 2. And then what? Exponentiate. So e both sides. So I get x equals e to the 1/2 y, or e to the y over 2. And then the other equation was this. So I'm going to multiply through by a 3. Maybe even a, whatever. I'm subtract a 3. And then multiply through by a -3. So x equals -3y plus 9. So I'm rotating. What's my whoa? What am I doing? So I gotta do the outer. So my radius is 12 minus that e function. So 12 minus the e. So pi, that's squared. Don't forget a dy this time. And what am I integrating from? Yeah, 0 to the y value now. 0 to 2.604. So there's your. Oh, and then I'm going to subtract the whole, which is what? Axis minus center. So 12 minus that 12 minus the negative 3y plus 9. Pi that squared dy that same interval. And again, you can simplify this. If it was an AP multiple choice question, you would see 12. Actually, you'd see 3y plus 3 squared. Yeah.
How's that second one the whole again? Isn't like all of the outer the e function?
Yeah, so the outer one, you're going axis minus the outer. But for the inner whole, you're going to go axis minus the inner. Right? And then, did I miss one? Oh, shell. And then same thing with the shell method. So, shell method, what do we got here? I think a lot easier. Well, maybe not. You're still going to have two things, right? Because you're going to have two heights. But it would not have been AP's intention for you to do it this way with two heights. It's totally fine. I mean, they're not thinking shell when they give you this. They're thinking this. So what do you got? 2 pi. Everybody loves the 2 pi. And then what? 12 minus x. Right? And again, just to kind of help you visualize it, say that was your height of your disk at this point. Well, the axis is not 12, and it's not that x value, it's this part. So you take the 12 and you subtract off the x value, and it gives you what you want. So again, that's why you're doing that over and over. And then what is your first height? Back to the original function, right? So 2 ln x minus 0 is the bottom. So just 2 ln x. Nothing squared on this, right? Because it's 2 pi r h. And this time you're integrating from what to what? 1 to 2.807. And then you're going to also go 2 pi 12 minus x, but this time 1/3 x plus 3 minus 0. So 1/3 x plus 3. Forgot the dx, don't do that. Give it a little width. And then this one, 2.007 to 9. Not too bad. So a couple of those would be kind of tricky. But tell you what, I think you and I are bored. We should have done the test today. I tell you what, on the back side of that, there are 6 problems. It's the same region rotated about 6 different axes. We only have, 20 minutes left in class? I'm going to give you 10 minutes. And then we'll just throw up the answers on the board. All right, so see what you can do with those. Actually, I'll probably just give you 15. Because it only takes a minute a piece to look at these, or tops. And then just brush up. We got everybody here, but no one. We get present. Hey, if you could write your name in this thing, if you lose it, kind of on you at that point, I guess. And every year somebody leaves one in here or shows somebody from the library brings one to me. Anybody know where Nolan is? Yeah. That is a terrible sound. So
They're the old ones, they're like yellowish.
it died.
They were so,
It was yellowish too. Think about this.
no, they're like the old ones that like you have when you're a freshman. Like every year you have one, it was like the color of your microwave.
Yeah, it had turned yellow in the sun. But I'd had it 25 years.
It
When I plugged it in, it just died.
oh,
Yeah. Man, that's terrible. Yeah, we used to have, back in the old days, literally our copiers didn't punch holes. Didn't stay whole. You had to do all that yourself, so that's why everybody had one that was super old. But anyway. Sure.
What is the plugins in our calculator?
That's you.
I'm in the.
Or something. I'll show you the work and the answer. Sorry?
Do you even need your calculator for this?
You need it?
You don't need it, it makes it a lot easier.
Yeah, you don't need it. Yeah.
I mean, that's a function.
Yeah.
So what do we do if we're not gonna be here on April 19th?
If you're not here on April the 19th. Well, I mean, if you miss something, you just make it up, I guess. Why?
I don't think a lot of people are gonna be here that day.
What's the
That's
19th?
the Monday.
That's the Monday.
Oh, yeah, that's right. Thanks for reminding me of that. Before I had children, I'd be like, too bad. But now I've had children. Yeah, I get it. Everybody's just delayed. So, I'll probably rework this then. We'll have to figure that out. That really kind of stinks, though. I'll play around with it. Thanks for pointing that out. I'm actually not going to be here right now on the. I don't know. We'll figure something out. Yeah, I'm not a tyrant. Hey, real quickly, guys. I want you to. I'm not going to be here. There's a 90% chance I'm not going to be here on Friday. Can y'all focus up? Where is she? Dang it. Come on, it's always. Oh well. I'll give her one more minute. Water. There she. Okay. So I've given you three things, and I'm saying this because you're going to need this on Fridays. Everybody tuned in. So on Friday, I'm getting that second shot on Thursday, and everybody's, it's like 9 out of every 10 people I talk to are like, oh yeah, you're not going to want to go to work. Don't even bother. Like one guy goes, yeah, I felt okay, but like at 1 o'clock, I was so tired, I literally couldn't get out of my chair. I was like, you literally couldn't get out of your chair. He goes, I'm not kidding you. Like I just felt like I just lost every ounce of energy I had. Whatever. So I'm taking off this Friday, which is a good day to take off because if you look at this Friday, what I had scheduled for you was to begin a diagnostic test in this book. Okay, so if you look, actually, you know what? I didn't check something. I hope not a whole lot changed. Sometimes they change this book. Diagnostic test 20. Sweet. Yeah. So 20, if you look on this book on page 20 through page 24, the problems that I have listed right there, I want you to take those, do those on the 12th, and I just won't be here. So you have a packet, and that packet, guys, that you just received, you're going to have a test over all the theorems and formulas in that packet on Thursday, the 18th. That'll be the last day before spring break, okay? And then your assignment for Friday, for that virtual day, I'm going to give you a take-home section of an AP test. It's just one, it's like a 50-minute section or whatever, maybe 55. It's got 27 questions on it. And your job will be on that Friday, that will be your asynchronous learning assignment. Just work on that Friday, or I don't care when, but we're going to be talking about it on the Monday we come back. So when we come back, I want you to have good questions. This diagnostic test that you're going to supposedly, well, not supposedly, whenever you want to take it, but it's assigned for Friday, we're going to be going over the problems in that on 16 and 17. There's no single way to improve your standing on this AP test than to take practice tests, mess up, and learn from them. Take tests, mess up, and learn from them. And I'm going to give you that diagnostic test, and you will have a full-length practice test that if you just do it, okay, there are going to be lots of days where you don't have any homework assignments. Look ahead. Tons of days. But the days that you do have from here on out, I mean, look, there are very few homework assignments. Not that y'all do a lot of homework anyway, a lot of you, but there are very few. When I give them, it's critical that you do them, because if you don't, you're going to be taking the real test for the first time, not knowing anything. You have to make these mistakes to get better. And but make sure you bring this book with you. If you're like, man, I know I'm going to forget. That's just who I am. Well, then take pictures of page 20, 21, 22, 23, 24, whatever. Take pictures of it now so you'll have it in your phone. I know you don't forget that, right? Because on Friday, you're going to need that to take that diagnostic test. You good? But guys, these formulas, most of the test is formulas, although like when you're looking at, there's a whole table of integration rules. There's a whole bunch of derivative rules. I might put slight, like on those things, like what's the natural, I mean, what is the integral of e to the x? Well, that's e to the x plus c, right? But I might put e to the 5x just to make sure you know how to do a u substitution. So basic problems, very basic, or just rules will be what that test is on. All right? And it's probably one of the harder tests because there's so many rules we have. You've got to look through everything. And then when you're looking down there, all the highlighted stuff, like multiple choice test B, free response test B, multiple choice test C, free response test C, those tests right there, those will count as grades, but I'm going to drop at least one of them. Okay, so your lowest one of, I will drop one if you improve, right? So most people do improve from first to second or second to third. But I'm looking to try to help you here. I'm definitely going to count the big test. That's the 300-pointer. Each section is roughly 75 points apiece. But on the other ones, I'm going 25, 25, 25, 25, and then 50, 50, 50, 50, and then on to the big one. And I think you'll be in really good shape if you take the review seriously. I see a lot of people every year, they just slacked off in my class pretty badly, but then they just they go, all right, I can do this. And they just got refocused for 2 months, which for you guys is not even 2 months, but got refocused for the last 6 weeks and brought that first quiz, the first test I gave them, like it was a 1, got it up to a 4, or a 2 up to a 5, just because they refocused and because you don't need to make 100 on this test to get 5. Y'all with me? Okay, got 5 minutes. Here are your, I don't know why I did it on notebook paper. Maybe I was at home, but here are your solutions to this. There's A and B. Well, actually, A, B, C, and D. Do what?
C and D are the same. The same 5 minutes.
Oh, yeah, yeah. Anybody have an issue? And again, simplifying these and putting -1 or instead of 1 squared. I mean, there are a lot of things you can do to simplify these, but like x minus a -2, put x plus 2, but you don't have to. And then there's E and F. So again, like 1 minus a -2, you can put 3 if you want. Anybody? You're getting everything we're doing today right. I would think you'd be in pretty decent shape. I mean, every year people are in pretty decent shape. If you need some last minute help, like if you've fallen lag behind and you're like, okay, I'm still struggling with something, drop by here after school. I'll be here probably till 4. I'm gonna go home and fix my irrigation system. Good times. Yes.
How in depth will we need to know immigration laws?
Like what you've been seeing. Like I'm not gonna rip out any inverse tangent on you or anything. Like it'd probably be more power rules or more than anything.
Yes, sir. On that Friday, the second year, where it says begin the diagnostic test, and then that's the problems right here. Is this a diagnostic test? Like, is the problem?
Those are the problems in the diagnostic. Yeah, guys, hey, he asked on the assignment sheet that it says page 2024. That's not your book. That's the problems in your, it's not the textbook or the book. It's the problems in this diagnostic test. Oh, I mean, it's the problems in this, on the diagnostic test in your new 5 Steps to a 5 book. And by the way, guys, if you forget, I like to think that all the books I've given you are pretty decent. Got a lot of stuff, but sometimes they're just problems and they're not explanations. In this 5 Steps to a 5, it's really pretty good. Like if you're wondering, oh man, I forgot all my limit rules. Flip to the limits section and read through limits. Oh, I forgot integration. Flip through that. Hopefully you guys are pretty solid, more solid than you probably realize. You're going to start seeing that when you start getting these practice tests graded and you're like, oh, wow. And you're doing better than you thought you would do. And most people come up 2 points or more. So like if the first one you make a 1, you'll get at least a 3. I mean, if you care. If you don't care, you won't. Or if you get a 3 on the first one, you probably get a 4 or 5. And most people do that if they're really in there. And I normally don't, I'm not able to give you 4. You're literally going to have 1, 2, 3, including the big test, 4. Count the diagnostic test, 4.5 practice tests we're going to go over. That's more than we've ever done. And I think that you'll benefit from that, really getting a good feel for what the test is like. And at that point, you just do the best you can. All right? All right.